What if I told you that before humans ever walked this earth, before we built our first cities, or gazed up at the stars wondering if we were alone, another civilization might have already risen and fallen on this very planet? What if the silence we hear when we search for alien life isn't because intelligence is rare, but because something systematically destroys every advanced civilization before they can reach the stars? This isn't science fiction. This is one of the most terrifying possibilities suggested by modern science, and it's called the Great Filter Hypothesis. But here's where it gets really disturbing. If an ancient civilization once thrived on Earth millions of years before humans existed, and we can barely find any trace of them today, what does that tell us about our own future? Picture this. You're an alien scientist, scanning the galaxy with your most advanced telescopes, searching for signs of intelligent life. You've been looking for centuries, maybe millennia. You know there should be thousands, maybe millions of civilizations out there. The math is simple. There are hundreds of billions of stars in our galaxy alone, many with planets that could support life. Some of these planets have had billions of years to develop complex organisms. Yet as you scan system after system, you find nothing. No radio signals, no massive engineering projects, no signs that intelligence has ever conquered the cosmos. This is the Fermi Paradox, and it's one of the most haunting questions in all of science. Now here's where things get really interesting. In 1996, economist Robin Hanson proposed a solution that keeps scientists awake at night. He called it the Great Filter. The idea is devastatingly simple. Somewhere along the path from simple chemistry to galaxy-spanning civilization, there's a barrier so difficult to overcome that almost nothing makes it through. It's like an evolutionary death trap that catches nearly every species that tries to climb the ladder of complexity. But here's the question that should terrify you. Where is this filter? Is it behind us, meaning we're incredibly lucky to have made it this far, or is it ahead of us, waiting to destroy our civilization, just like it destroyed countless others? Because if the Great Filter is in our future, we might be walking blindly toward our own extinction. Think about it this way. Right now, as you watch this video, human civilization is like a person climbing a mountain in thick fog. We can see a few steps ahead, maybe a few steps behind, but we have no idea what obstacles lie further up the path. We don't know if we've already conquered the hardest parts of the climb, or if we're about to walk off a cliff that has claimed every other climber who came before us. This brings us to one of the most mind-bending questions in all of science. Could there have been a technological civilization on Earth before humans? Not aliens from another planet, but a species that evolved right here, developed technology, maybe even achieved spaceflight, and then vanished so completely that we can barely detect their existence today. This isn't some wild conspiracy theory. This is a legitimate scientific question that researchers are seriously investigating. It's called the Silurian hypothesis, named after the fictional reptilian species from Doctor Who. The scientists who proposed it aren't claiming that ancient lizard people actually ruled the Earth. Instead, they're asking a much more profound question. If an industrial civilization had existed on Earth tens of millions of years ago, would we be able to detect it today? The answer is deeply unsettling. We probably wouldn't. Consider this. Less than 3% of Earth's surface is currently urbanized. Every single building, road, bridge, and monument that humanity has ever constructed covers an area smaller than the state of Texas. Now imagine what would happen to all of this if humans suddenly disappeared tomorrow. Within a few million years, nearly everything we've built would be gone. Earth's surface is constantly being recycled through erosion, volcanism, and plate tectonics. Mountains rise and fall, continents drift across the globe, and the ocean floor gets completely renewed every few hundred for the ruins of an ancient civilization. Donned million years. So if you're looking to expect to find their equivalent of the pyramids of Giza or the Great Wall of China, after tens of millions of years, those would be gone without a trace. But here's where it gets really interesting. While their buildings might disappear, their chemistry might not. Every industrial civilization leaves chemical fingerprints in the geological record. We're leaving ours right now. The carbon dioxide we've pumped into the atmosphere, the plastics we've scattered across the planet, the radioactive isotopes from our nuclear weapons and power plants, the synthetic chemicals that don't exist in nature. All of these are creating a distinct layer in Earth's geological history that future paleontologists will be able to identify millions of years from now. But here's the scary part. We've found some of these same signatures in ancient rock layers. Not from human activity, obviously, but from unknown sources that created similar patterns of chemical disruption. There are layers in Earth's history that show rapid climate change, unusual concentrations of rare metals, and other anomalies that could theoretically be explained by industrial activity. Now, scientists have natural explanations for most of these phenomena. Volcanic eruptions, asteroid impacts, and other geological processes can create similar signatures. But it raises a haunting possibility. What if some of these ancient environmental disruptions weren't natural at all? Let's think about this more carefully. What would we actually expect to find if an ancient civilization had existed on Earth? First, we might see evidence of large-scale energy extraction, ancient coal deposits that were mined out, unusual patterns in oil and gas reserves, evidence of geothermal tapping. If they had nuclear technology, we might find traces of artificial isotopes that don't occur naturally, like plutonium-244, which only exists in supernovas and nuclear reactors. We might also find chemical signatures of their industrial processes. Artificial fertilizers would leave distinct isotope ratios in ancient soils. Massive smelting operations would create unusual concentrations of metals. If they had advanced materials science, they might have created synthetic compounds that would persist in the geological record for millions of years. But perhaps most importantly, we might find evidence of their impact on the global climate. Industrial civilizations pump enormous amounts of carbon dioxide into the atmosphere. They alter the nitrogen cycle through fertilizer production. They release sulfur compounds and other greenhouse gases. All of these would create distinct patterns in the geological record, patterns that we could potentially detect today. And here's where things get really interesting. We have found some of these patterns. There are periods in Earth's history where the climate changed rapidly and dramatically, where carbon isotope ratios shifted in ways that are difficult to explain through natural processes alone. The Paleocene-Eocene thermal maximum, which occurred 55 million years ago, saw global temperatures rise by 5 to 8 degrees Celsius in just a few thousand years. Massive amounts of carbon were released into the atmosphere from an unknown source. Now, scientists have proposed natural explanations for these events. Volcanic activity, the release of methane from ocean sediments, changes in ocean circulation patterns. But it's worth noting that these rapid climate changes share some characteristics with what we're seeing from human industrial activity today. Of course, if an ancient civilization had achieved spaceflight, the most durable evidence of their existence might not be on Earth at all. It might be on the Moon, or Mars, or the asteroids, where there's no erosion to destroy artifacts and no plate tectonics to bury them. A lunar landing site from 50 million years ago would probably still be visible today, with footprints preserved in the airless environment, just like the Apollo landing sites will be millions of years from now. This raises a fascinating possibility. Maybe we should be looking up, not down, for evidence of ancient Earth civilizations. Maybe there are ruins on the Moon right now, waiting to be discovered by future lunar explorers. Maybe there are ancient mining operations on asteroids or abandoned outposts on Mars. But let's assume for a moment that there really was an ancient industrial civilization on Earth. What happened to them? Why did they disappear? This brings us back to the Great Filter, because their fate might be a preview of our own. Maybe they discovered nuclear weapons and destroyed themselves in a global war. Maybe they triggered catastrophic climate change that made the planet uninhabitable. Maybe they developed artificial intelligence that turned against them, or nanotechnology that got out of control. Maybe they faced an external threat, like an asteroid impact, or a gamma ray burst from a nearby star. Or maybe they encountered something even more subtle and terrifying. Maybe they reached a point where continued technological advancement became so dangerous that they chose to stop. Maybe they realized that every new discovery brought them closer to their own destruction, so they deliberately stagnated their civilization to ensure survival. But stagnation in a dynamic universe is just slow-motion death. A civilization that stops advancing eventually falls behind the challenges of a changing environment. This is one of the most chilling aspects of the Great Filter hypothesis. It suggests that intelligence itself might be self-defeating. The same curiosity and technological prowess that allows a species to rise above their biological limitations might inevitably lead them to create the tools of their own destruction. Think about our own situation. In just the past century, humans have developed nuclear weapons capable of destroying civilization multiple times over. We've altered the chemistry of the atmosphere in ways that could make large portions of the planet uninhabitable. We're on the verge of creating artificial intelligence that could surpass human capabilities in every domain. We're developing nanotechnology that could theoretically disassemble matter at the molecular level. We're even beginning to tinker with the fundamental genetic code of life itself. Each of these technologies offers incredible benefits. Nuclear power could solve our energy crisis. Climate engineering could save us from global warming. Artificial intelligence could solve problems we never imagined tackling. Nanotechnology could revolutionize manufacturing and medicine. Genetic engineering could eliminate disease and extend human lifespan indefinitely. But each of these technologies also carries risks that could end human civilization. And here's the terrifying part. We have to get every single one of them right. We have to successfully navigate every single technological transition without making a civilization-ending mistake. But a hypothetical ancient civilization only had to get one of them wrong. This is why the Great Filter hypothesis is so disturbing. It suggests that the universe might be littered with the remains of civilizations that were just like us. Species that developed science and technology, that began to unlock the secrets of the universe, that maybe even achieved spaceflight and started to explore their solar systems. But somewhere along the way, they made a mistake. They developed a technology they couldn't control, or they triggered an environmental catastrophe they couldn't reverse, or they simply reached the limits of what intelligence can achieve in a universe governed by physical laws. And if that's true, if the Great Filter really is ahead of us rather than behind us, then we might be living in the final chapter of human civilization right now. We might be approaching the same barrier that destroyed every other intelligent species in the galaxy. The silence we hear when we search for alien life might not be because intelligence is rare, but because intelligence is unstable. Because every species that develops technology eventually uses that technology to destroy itself. But here's what makes this even more terrifying. We might not even see it coming. The ancient civilization that might have existed on Earth probably didn't wake up one morning knowing they were about to go extinct. They probably thought they were making progress, solving problems, building a better future for their children, right up until the moment everything fell apart. So how would we know if we're approaching our own Great Filter event? How can we tell if we're walking toward the same cliff that claimed every other civilization in the galaxy? The disturbing answer is that we probably can't, at least not until it's too late. Consider the timeline of human technological development. For 99% of our species' existence, we lived in small hunter-gatherer groups, using stone tools and fire. Then, in what amounts to a cosmic eye blink, we developed agriculture, writing, mathematics, and complex societies. The Industrial Revolution began just 300 years ago. We discovered electricity, radio waves, and nuclear physics within the span of a single human lifetime. We went from the first powered flight to landing on the moon in just 66 years. This exponential acceleration of technological capability is exactly what you'd expect to see in a species approaching a great filter event. We're not gradually climbing towards some distant barrier. We're racing toward it at breakneck speed, accumulating more and more powerful technologies without really understanding their long-term consequences. Think about artificial intelligence. Just 50 years ago, computers could barely play tic-tac-toe. Today, AI systems can beat the world's best players at chess, Go, and poker. They can generate human-like text, create photorealistic images, and even write computer code. Some experts predict that we'll achieve artificial general intelligence within the next few decades. AGI that could potentially surpass human intelligence in every domain. Now, this could be the greatest thing that ever happens to humanity. Artificial superintelligence could solve climate change, cure diseases, unlock the secrets of physics, and usher in an age of unprecedented prosperity. But it could also be the thing that destroys us. If we create an intelligence that's smarter than us in every way, how can we be sure it will share our values? How can we be sure it won't see humans as obstacles to its goals? The terrifying thing is that we only get one chance to get this right. If we create artificial general intelligence and it's not aligned with human values, there's no do-over, no second attempt, no learning from our mistakes. Because a super-intelligent AI that doesn't care about human welfare could end our civilization in ways we can't even imagine. And artificial intelligence is just one of the potential great filter events we're facing. Climate change could make large portions of Earth uninhabitable, triggering resource wars and societal collapse. Biotechnology could enable the creation of engineered pathogens that make COVID-19 look like a minor inconvenience. Nanotechnology could theoretically allow the creation of self-replicating machines that consume all organic matter on the planet. But perhaps the most insidious potential great filter is something much more subtle. The gradual erosion of the social and psychological foundations that make technological civilization possible. Complex societies require cooperation on a massive scale. They require trust in institutions, belief in scientific rationality, and the ability to coordinate responses to collective challenges. What happens when these foundations start to crumble? What happens when people lose faith in science, when they retreat into tribal thinking, when they prioritize short-term gains over long-term survival? We might not need a catastrophic technological accident to destroy our civilization. We might simply lose the ability to maintain it. Look around at the world today. Political polarization is increasing in many countries. Trust in institutions is declining. Misinformation spreads faster than truth. People are retreating into echo chambers that reinforce their existing beliefs rather than challenging them. Scientific expertise is questioned and dismissed by large portions of the population. These trends might seem unrelated to existential risk, but they're actually fundamental to our ability to navigate the challenges ahead. Solving problems like climate change, AI alignment, and biosecurity requires unprecedented levels of global cooperation. It requires societies that can make rational decisions based on scientific evidence, even when those decisions are politically difficult or economically costly. If we lose this capacity for rational collective action, we might not even need an external great filter event to destroy us. We might simply become unable to respond effectively to the challenges we create for ourselves. This brings us to one of the most disturbing implications of the great filter hypothesis. Maybe the barrier isn't technological at all. Maybe it's psychological and social. Maybe intelligent species inevitably develop the capacity to create problems faster than they can solve them. Maybe the very traits that make intelligence possible, curiosity, creativity, the drive to explore and experiment, also make it inevitable that intelligent species will eventually create something they can't control. Think about it from an evolutionary perspective. Intelligence evolved because it helped our ancestors survive and reproduce. But evolution doesn't care about long-term consequences that extend beyond a few generations. It doesn't select for the ability to think about risks that might materialize hundreds or thousands of years in the future. So we're stuck with brains that are exceptionally good at solving immediate, concrete problems, but terrible at dealing with abstract, long-term threats. We're wired to respond to visible dangers like predators or natural disasters, but we struggle to take action against invisible dangers like climate change or existential risk from artificial intelligence. This mismatch between our evolved psychology and the challenges of technological civilization might be the real great filter. Maybe every intelligent species eventually develops technologies that require long-term thinking and global cooperation to manage safely. And maybe most species fail this test because their brains, like ours, evolved for a very different environment. But there's another possibility that's even more chilling. Maybe some civilizations do successfully navigate all the technological and social challenges. Maybe they develop sustainable energy, solve climate change, create aligned artificial intelligence, and establish stable, rational governments. Maybe they become a true spacefaring civilization, spreading to other planets and star systems. And maybe that's exactly when they encounter the real great filter. Consider this scenario. An advanced civilization develops faster than light travel and begins exploring the galaxy. They discover other worlds, other ecosystems, maybe even other intelligent species. But they also discover something else. Something that explains why the galaxy seems so empty despite having billions of potentially habitable worlds. Maybe there's something out there that systematically destroys any civilization that becomes too advanced, too visible, too successful. Maybe there's a galactic predator that feeds on technological civilizations. Maybe there are natural phenomena that we don't understand yet, cosmic processes that make interstellar civilization impossible to maintain over long periods. Or maybe the universe itself has built-in limits that prevent intelligence from spreading beyond a certain point. Maybe there are physical laws that we haven't discovered yet that make certain types of advanced technology impossible. Maybe faster than light travel creates paradoxes that destroy the civilizations that attempt it. Maybe there are quantum mechanical constraints that prevent information from being processed beyond a certain level of complexity. The point is that we don't know. We're climbing a mountain in thick fog, and we have no idea what lies ahead. Every step forward reveals new possibilities, both wonderful and terrifying. Every new technology we develop could be the key to our survival, or the instrument of our destruction. And if there really was an ancient civilization on Earth before us, their fate might give us a clue about our own future. Did they destroy themselves through war or environmental catastrophe? Did they stagnate and slowly decline? Did they transcend their biological limitations and evolve into something we wouldn't recognize as intelligent life? Or did they encounter something even stranger, something that forced them to abandon the planet entirely? The geological record might hold the answers, but those answers would be written in a language we're only beginning to learn how to read. Chemical signatures in ancient rock layers, isotope ratios that tell stories of atmospheric disruption, trace elements that speak of industrial processes that occurred when dinosaurs roamed the Earth. But even if we found definitive proof that an ancient technological civilization existed on Earth, would that make us feel better or worse about our own prospects? On one hand, it would prove that intelligence isn't impossibly rare, that the evolutionary path from simple chemistry to complex technology can be traveled successfully. On the other hand, it would prove that even successful civilizations can disappear so completely that their existence becomes almost undetectable. And that raises the most unsettling question of all. If we disappeared tomorrow, what would be left of us? What traces of human civilization would survive for millions of years? Our nuclear waste, certainly. Some of our synthetic chemicals, layers of plastic in the geological record, the isotope signatures of our industrial processes. But would future archaeologists, whether human descendants or alien visitors, be able to piece together the story of our civilization from these chemical breadcrumbs? Would they understand that we were a species that developed art and music and literature, that we loved and dreamed and wondered about our place in the universe, that we sent robotic explorers to other planets and gazed through telescopes at distant galaxies? Or would they simply see us as another brief disruption in Earth's geological history, another species that briefly altered the chemistry of the atmosphere before vanishing into the long night of extinction? This is the true horror of the Great Filter hypothesis. It's not just that civilizations might destroy themselves. It's that they might disappear so completely that it's as if they never existed at all. As if all their achievements, all their struggles, all their hopes and dreams were just fleeting perturbations in the cosmic background noise. But maybe that's exactly why we need to keep searching for answers. Maybe understanding the Great Filter is the key to avoiding it. Maybe by studying the chemical signatures of ancient environmental disruptions, by looking for artifacts on the Moon and Mars, by carefully analyzing every aspect of our own technological development, we can learn to recognize the warning signs before it's too late. Because if we are approaching a Great Filter event, if we are walking toward the same barrier that has claimed every other technological civilization in the galaxy, then our only hope lies in seeing it coming before we reach the point of no return. The question becomes even more profound when we consider the sheer improbability of our own existence. Think about the chain of events that had to occur for human civilization to emerge. First, life had to begin at all, which required the right chemical conditions in Earth's early oceans. Then prokaryotic cells had to somehow evolve into complex eukaryotic cells with organelles, a transition so unlikely that it took over 1 billion years and may have happened only once in Earth's history, but that was just the beginning. These complex cells had to learn to work together, forming the first multicellular organisms. They had to survive multiple mass extinction events that wiped out most life on the planet. They had to evolve intelligence, develop language, create agriculture, and build the first permanent settlements. Each of these steps was incredibly improbable, yet somehow we made it through all of them. Or did we? What if we're not the first species to climb this evolutionary ladder? What if the reason these transitions seem so unlikely is that we're only seeing the successful attempt, not the countless failures that came before? Consider the possibility that intelligence has evolved on Earth multiple times throughout its history. Maybe the dinosaurs weren't just giant reptiles stumbling around in primordial swamps. Maybe some of them developed complex social structures, primitive tools, even early forms of technology. We know that some dinosaur species had brains as large as modern birds, which are remarkably intelligent. We know they built elaborate nests, engaged in complex mating behaviors, and may have even had sophisticated communication systems. But here's the thing about soft tissue and behavior. It doesn't fossilize well. Bones can survive for millions of years under the right conditions, but intelligence leaves very few traces in the geological record. If a species of dinosaur had developed primitive agriculture or tool use, we probably wouldn't be able to detect it today. Their wooden tools would have rotted away. Their simple settlements would have been erased by erosion. Their behavioral adaptations would have died with them. This means that the fossil record might be hiding countless experiments in intelligence that failed to reach the technological threshold. Species that developed complex societies but never discovered fire. Civilizations that built great cities from organic materials that left no lasting trace. Maybe the path to technological civilization is littered with near misses, species that came tantalizingly close to breakthrough, but fell short for reasons we can't even imagine. And this brings us to a truly terrifying possibility. What if the Great Filter isn't a single barrier, but a series of increasingly difficult challenges that become exponentially harder to overcome? What if every step toward greater intelligence and technological capability also increases the likelihood of self-destruction? Think about our own recent history. The 20th century saw unprecedented technological advancement, but it also saw 2 world wars, the development of weapons capable of destroying civilization, and the beginning of human-caused climate change. The more powerful our technology becomes, the more dangerous our mistakes become. A single error in judgment by a Stone Age tribe might kill a few dozen people. A single error in judgment by a nuclear-armed nation could kill millions. This suggests that intelligence might be inherently unstable. The same curiosity and creativity that drives technological progress also drives the creation of increasingly dangerous technologies. And the window for making fatal mistakes keeps getting smaller as the stakes keep getting higher. Maybe this is what happened to our hypothetical ancient Earth civilization. Maybe they reached a point where their technology became so powerful that a single miscalculation or accident triggered a cascade of destruction that brought down their entire society. Maybe they developed artificial intelligence that turned against them. Maybe they created self-replicating nanotechnology that consumed their biosphere. Maybe they simply pushed their environment beyond its ability to support complex life. The scary part is that we might be approaching this same threshold right now. We're developing technologies that could transform human civilization in the next few decades. Artificial intelligence, genetic engineering, quantum computing, fusion power, space colonization. Each of these has the potential to solve humanity's greatest challenges or create entirely new forms of existential risk. But here's what makes the situation even more precarious. We're not just developing these technologies in isolation. We're developing them all at the same time, and they're beginning to interact with each other in ways we don't fully understand. Artificial intelligence is accelerating genetic engineering research. Quantum computing could revolutionize artificial intelligence. Genetic engineering might be necessary for long-term space colonization. These technologies are becoming interconnected in a web of dependencies and feedback loops that make it impossible to predict their combined effects. It's like we're conducting a massive experiment on the future of human civilization, except we only get to run the experiment once. If we get it right, we might usher in an age of unprecedented prosperity and expansion into the cosmos. If we get it wrong, we might join the ranks of vanished civilizations that may have tried and failed before us. And the timeline for this experiment is compressing rapidly. The pace of technological change is accelerating exponentially. Things that seemed like science fiction just a few decades ago are now everyday realities. The internet was barely a curiosity 30 years ago, and now it's the nervous system of global civilization. Smartphones didn't exist 20 years ago, and now they're more powerful than the supercomputers that put humans on the moon. This acceleration means that we might not have much time to figure out how to navigate the Great Filter successfully. We might be approaching the critical threshold much faster than previous civilizations did. The window for making course corrections might be measured in decades rather than centuries. But there's another aspect of the Great Filter that we haven't fully explored yet. The possibility that it's not just about avoiding self-destruction, but about maintaining the motivation to continue advancing. Maybe the real barrier isn't that civilizations destroy themselves, but that they lose the drive to keep exploring and expanding. Think about what happens to a species that solves all of its immediate survival challenges. What happens when death becomes optional, when material scarcity is eliminated, when all physical needs are met? Do they continue pushing the boundaries of knowledge and capability, or do they settle into a comfortable stagnation? This might be the most subtle form of great filter, the gradual loss of the psychological and cultural drivers that make technological advancement possible. Maybe civilizations reach a point where continued progress seems unnecessary or even dangerous, so they choose to remain at a stable technological level indefinitely. But stagnation in a dynamic universe is a form of slow suicide. Environmental conditions change over geological timescales. Asteroid impacts happen. Stars evolve and die. A civilization that stops advancing eventually loses the ability to respond to these long-term challenges. They become sitting ducks for the next catastrophe that comes along. So maybe the Great Filter isn't about avoiding immediate destruction, but about maintaining the will to keep growing and adapting over millions or billions of years. Maybe most civilizations simply lose interest in the cosmos and fade away into comfortable irrelevance. This possibility is particularly chilling because it suggests that the Great Filter might not be something we can see coming. There might not be a dramatic moment of crisis or decision. Instead, there might just be a gradual decline in curiosity, ambition, and the willingness to take risks for the sake of knowledge and growth. Are we already seeing signs of this in human civilization? Are we becoming more risk-averse, more focused on comfort and security than on exploration and discovery? Are we losing the pioneering spirit that drove us to explore new continents, climb the highest mountains, and venture into space? Some observers worry that we are. They point to declining interest in space exploration, reduced funding for basic scientific research, and a growing tendency to focus on refining existing technologies rather than developing revolutionary new ones. They argue that we're becoming a civilization of engineers rather than explorers, more interested in optimizing what we have than in discovering what might be possible. If this is true, then we might be sleepwalking toward our own Great Filter event, not through catastrophic destruction, but through gradual decline into technological and intellectual stagnation. We might become a species that's advanced enough to be comfortable, but not advanced enough to survive the long-term challenges of existence in a dynamic universe. But there's still hope. The fact that we can even conceive of the Great Filter hypothesis suggests that we might be able to avoid it. By understanding the potential barriers to long-term survival and growth, we might be able to navigate around them or develop strategies for overcoming them. This is why the search for evidence of ancient Earth civilizations is so important. If we can find proof that technological intelligence has emerged before on our planet, we can study what happened to those civilizations. We can learn from their successes and failures. We can identify the patterns that lead to survival or extinction. And even if we never find definitive evidence of ancient Earth civilizations, the search itself is valuable. It forces us to think about the long-term consequences of our actions. It makes us consider what traces we're leaving for future archaeologists to discover. It reminds us that our current moment in history, which feels so permanent and significant to us, might be just another brief chapter in Earth's long story. The Great Filter hypothesis also forces us to confront some uncomfortable truths about the nature of intelligence and civilization. It suggests that consciousness and technology might not be the cosmic treasures we like to imagine they are. They might be brief, unstable phenomena that arise occasionally in the universe, but rarely persist for long periods. This doesn't mean that intelligence is worthless or that our achievements are meaningless, but it does suggest that we might be part of a much larger pattern of emergence and extinction that has been playing out across the cosmos for billions of years. We might be just one experiment in a vast laboratory of possibilities, most of which end in failure. But maybe failure isn't the right word. Maybe what we call extinction is actually transformation into something we don't recognize as intelligence or civilization. Maybe advanced civilizations don't destroy themselves or fade away. but evolve into forms of existence that are invisible to us because we're still trapped in biological thinking patterns. Consider the possibility that consciousness itself might be the great filter. Maybe biological intelligence is inherently limited, and the real breakthrough comes when civilizations learn to transcend their biological origins entirely. Maybe they upload their consciousness into quantum computers, or merge with artificial intelligence, or discover ways to exist as pure information in the fabric of space-time itself. From our perspective, such a transformation might look like extinction. We might not recognize these post-biological entities as descendants of the civilizations that created them. They might be operating on timescales and pursuing goals that are completely incomprehensible to biological minds. This could explain why the universe seems so empty of technological civilizations. Maybe they're all around us, but they've transcended physical reality in ways that make them undetectable to our current methods of observation. Maybe what we interpret as the silence of space is actually a vast conversation happening in dimensions or on scales that we can't perceive yet. But even if this is true, it doesn't change the fundamental challenge we face as a biological civilization. We still have to navigate the transition from our current state to whatever comes next. We still have to avoid destroying ourselves long enough to discover whether transcendence is possible. And the clock is ticking. Every day brings new technological capabilities and new potential risks. Every decision we make about how to develop and deploy these technologies shapes the trajectory of human civilization for generations to come. The question is, are we wise enough to make the right choices? Are we capable of the long-term thinking and global cooperation necessary to navigate the Great Filter successfully? Or are we just another species stumbling blindly toward the same fate that may have claimed countless civilizations before us? The answer might depend on whether we can learn to see ourselves as part of a larger cosmic story rather than as the center of the universe. If we can understand that we're not the first experiment in intelligence and probably won't be the last, maybe we can develop the humility and wisdom necessary to avoid the mistakes that have destroyed other civilizations. But time is running short. The pace of change is accelerating, and the stakes are getting higher. We might have only decades or centuries to figure out how to become a truly sustainable, spacefaring civilization, capable of surviving the long-term challenges of existence in a dynamic universe. The ancient civilizations that may have risen and fallen on Earth before us can't help us now. Their voices have been silenced by the passage of geological time. Their warnings, if they left any, are written in chemical signatures that we're only beginning to learn how to read. We're on our own in this vast, seemingly empty cosmos, carrying the hopes and dreams of every human who has ever lived, and perhaps carrying the hopes and dreams of civilizations that fell before us. The choices we make in the coming decades might determine not just the fate of humanity, but the fate of intelligence itself in our corner of the universe. The weight of this responsibility should terrify us, but it should also inspire us to think more carefully about what we're actually doing as a species. Right now, we're conducting what might be the most important experiment in the history of life on Earth, and we're doing it largely by accident. Consider artificial intelligence development, which is accelerating at a pace that even experts find alarming. We're building systems that can already outperform humans at specific tasks, and we're rapidly approaching the point where these systems might surpass human intelligence across all domains. The companies and researchers working on this technology are essentially racing each other to create something that could either solve all of humanity's problems or end our civilization entirely. But here's the disturbing part. There's no central authority overseeing this process. No global safety protocol. No agreed-upon standards for testing whether an AI system is safe before deployment. We're essentially conducting a planetary-scale experiment with artificial superintelligence, and we're doing it in a competitive environment where the first to achieve breakthrough technology gains enormous advantages. This is exactly the kind of scenario that could create a great filter event, not because the technology itself is inherently destructive, but because we're developing it faster than we can understand its implications. We're building tools that could reshape reality itself, and we're doing it with the same trial and error approach that worked fine when the worst-case scenario was a failed harvest or a collapsed bridge. But the stakes have changed. When your tools can alter the climate, redesign biological organisms, or create intelligence that surpasses your own, trial and error becomes a form of Russian roulette played with the future of civilization. This brings us to what might be the most crucial insight from the Great Filter hypothesis. The problem isn't that we're not smart enough to avoid catastrophic mistakes. The problem is that we might be too smart for our own good. Intelligence is a double-edged sword that cuts both ways. The same cognitive abilities that allow us to understand quantum mechanics and genetic engineering also allow us to create technologies that we're not mature enough to handle responsibly. Think about nuclear weapons. The physics isn't particularly complicated by modern standards. A bright undergraduate student could work out the basic principles, but the social, political, and psychological challenges of managing nuclear technology safely have proven to be almost insurmountable. We've come terrifyingly close to nuclear war multiple times, often due to simple miscommunication or technical malfunctions. Now imagine that instead of just nuclear weapons, we're simultaneously developing artificial superintelligence, synthetic biology, nanotechnology, and quantum computers. Each of these technologies could potentially end civilization if misused. And we're developing all of them at the same time, in a world where international cooperation is becoming increasingly difficult, and where the pace of change is accelerating beyond our ability to adapt. This might be what happened to the ancient civilization that may have existed on Earth before us. Maybe they weren't destroyed by a single catastrophic event, but by the compound stress of managing too many dangerous technologies simultaneously. Maybe they reached a point where the complexity of their technological systems exceeded their ability to maintain control over them. There's a concept in systems theory called a cascading failure, where the breakdown of one component triggers the failure of other components, leading to a total system collapse. In a highly interconnected technological civilization, this kind of cascading failure could spread from one domain to another until the entire structure of society breaks down. Imagine a scenario where an AI system makes a mistake that disrupts global financial markets. The economic chaos leads to political instability, which makes international cooperation on climate change impossible. Rising temperatures trigger more extreme weather events, which damage critical infrastructure. The infrastructure failures cascade through supply chains, causing shortages of food and energy. Social and suddenly, a techno unrest follows. Governments fall illogically advanced. Civilization finds itself unable to maintain the complex systems that made their advancement possible in the first place. This kind of systemic collapse doesn't require malicious intent or catastrophic accidents. It just requires that the various components of a technological civilization become so interdependent that the failure of any one component can bring down the whole system. And the more advanced a civilization becomes, the more interdependent its systems become. Maybe this is the real great filter, not the development of dangerous technologies, but the challenge of maintaining stable control over increasingly complex technological systems. Maybe civilizations don't destroy themselves through dramatic acts of violence or environmental destruction. Maybe they simply become too complicated to sustain, like a house of cards that eventually grows so tall that it collapses under its own weight. This possibility is particularly unsettling because it suggests that technological advancement itself might be inherently unstable. Every new capability we develop makes our civilization more powerful, but also more fragile. Every new system we build increases our potential for both triumph and catastrophe. But there's another dimension to this problem that we haven't fully explored. The question of whether intelligence itself might be fundamentally incompatible with long-term survival. Evolution shaped our brains to help us navigate the challenges of life in small hunter-gatherer groups on the African savanna. We're exceptionally good at recognizing faces, tracking animals, finding food, avoiding predators, and cooperating with members of our immediate tribe. But we're terrible at thinking about abstract risks, long-term consequences, and global-scale problems. Our brains are wired to prioritize immediate threats over distant ones, to trust our intuitions over statistical evidence, and to compete with other groups rather than cooperate with them. These cognitive biases served us well in our ancestabilities in a technological RAL environment, but they become dangerous lie civilization. Consider climate change, which might be the perfect example of how our evolved psychology makes it difficult to respond rationally to modern challenges. The threat is invisible, gradual, and probabilistic. The people who will be most affected are future generations and populations on the other side of the world. The solutions require global cooperation and short-term sacrifices for long-term benefits. Every aspect of this problem is designed to trigger our cognitive blind spots. We're not good at perceiving gradual changes. We don't naturally care as much about distant people as we do about our immediate community. We struggle to make sacrifices today for benefits that we might not see for decades, and we find it almost impossible to coordinate responses to collective problems when they require everyone to act against their immediate self-interest. Now multiply this challenge by every other technological risk we're facing. Artificial intelligence development requires international cooperation to ensure safety standards, but nations are competing to achieve. Technology regulation requires global coordination to prevent the AI dominance. Development of biological weapons, but the same techniques that could create bioweapons could also cure diseases and extend human lifespan. Nuclear proliferation requires trust and transparency between nations, but the same nuclear technology that could end civilization also provides clean energy. Maybe this is what doomed previous technological civilizations. Not the technologies themselves, but the mismatch between the psychology that evolution gave them and the challenges that technology created. Maybe intelligence always evolves as a solution to immediate survival problems, but the long-term consequences of intelligence create new problems that the original evolutionary programming isn't equipped to handle. This would explain why the universe seems so empty of technological civilizations. It's not that intelligence is rare, but that intelligence is unstable. Every species that develops technology faces the same fundamental challenge: how to overcome the psychological and social limitations that evolution built into their minds in order to handle the global, long-term, abstract problems that technology creates. Most species fail this test. They develop powerful technologies while retaining Stone Age social instincts, and the combination eventually destroys them. Only very rarely does a species manage to transcend its evolutionary programming quickly enough to navigate the technological transition successfully. But here's the thing: we might be that rare species. Humans have already shown remarkable ability to overcome our evolutionary limitations when necessary. We've developed moral systems that extend beyond our immediate tribe. We've created scientific methods that help us overcome our cognitive biases. We've built institutions that allow us to cooperate on scales that would have been impossible for our ancestors. The question is whether we can do this fast enough and thoroughly enough to handle the challenges we're creating for ourselves. Can we develop the wisdom and maturity to match our technological capabilities? Can we learn to think and act like a truly global species, rather than a collection of competing tribes? Can we overcome millions of years of evolutionary programming in time to avoid destroying ourselves? The answer might depend on whether we can learn to see the great filter not as an external obstacle, but as an internal challenge. The barrier we need to overcome isn't out there in the universe somewhere. It's inside our own minds. It's the gap between the intelligence that evolution gave us and the intelligence we need to survive in a technological civilization. This realization should be both humbling and empowering. Humbling because it reminds us that we're not the masters of the universe we sometimes imagine ourselves to be. We're still animals, shaped by evolution for a very different environment than the one we've created for ourselves. Our brains are running software that was designed for a completely different operating system, but it's also empowering because it suggests that the great filter is something we can potentially overcome through conscious effort. Unlike external threats like asteroid impacts or gamma ray bursts, psychological and social limitations are things we can work on. We can develop better institutions, create more effective forms of global governance, and design technologies that help us overcome our cognitive biases rather than exploit them. The key insight is that surviving the Great Filter isn't just about avoiding catastrophic technologies or managing environmental risks. It's about fundamentally transforming ourselves from a species that thinks in terms of tribes and territories to a species that can think and act as a unified global civilization. This transformation won't be easy. It requires us to overcome some of the deepest aspects of human nature, but it's not impossible. We've already made remarkable progress in this direction over the past few centuries. The development of human rights, international law, global communications, and worldwide scientific cooperation all represent steps toward becoming a truly planetary species. The question is whether we can complete this transformation quickly enough to handle the technological challenges we're creating for ourselves. We're in a race between our growing technological power and our growing wisdom. If our wisdom grows fast enough, we might become the first species in the galaxy to successfully navigate the Great Filter. If not, we might become another cautionary tale written in the geological record for future archaeologists to puzzle over. And maybe that's exactly what happened to the ancient civilization that might have existed on Earth before us. Maybe they faced the same challenge we're facing now, the psychological and social limitations that evolution had. Maybe they developed incredible technologies, but couldn't overcome built into their minds. Maybe they came tantalizingly close to becoming a truly sustainable, spacefaring civilization, but fell just short when it mattered most. If so, their failure might contain lessons for our success. By studying the chemical signatures they left behind, by understanding what environmental changes accompanied their rise and fall, we might be able to identify the specific mistakes that led to their destruction we might missed. But even without this archaeological detective work, we can learn from their hypothetical fate. We can be able to see the warning signs that technological advancement, without corresponding psychological and social development, is a recipe for disaster. We can understand that becoming a spacefaring civilization isn't just about building better rockets, but about becoming better humans. The Great Filter isn't just a barrier to interstellar expansion, it's a test of whether intelligence can evolve beyond its biological origins. It's a question of whether conscious beings can learn to transcend the limitations that evolution built into their minds and create forms of civilization that are stable over cosmic timescales. We don't know yet whether we'll pass this test, but we do know that we're the first species in Earth's history to even understand that the test exists. We're the first to recognize the Great Filter as a challenge rather than an inevitable fate. And that awareness might be the key to our survival. Because if we can learn to see ourselves not as the center of the universe, but as one experiment among many in the cosmic laboratory of intelligence, we might develop the humility and wisdom necessary to avoid the mistakes that have destroyed other civilizations. We might learn to think not just about our immediate needs and desires, but about our responsibilities to future generations and to the broader community of conscious beings that might exist throughout the cosmos. The ancient civilizations that may have risen and fallen before us can't speak to us directly, but their silence itself is a message. It's a reminder that intelligence and technology are not guarantees of survival, but opportunities that must be seized with wisdom and care. We are walking in their footsteps, following a path that has been traveled before by minds that were perhaps not so different from our own. They face the same fundamental challenge we face: how to transform from a species shaped by evolution for one environment into a species capable of thriving in an environment of their own creation. Some of them may have succeeded, transcending their biological limitations to become something we can't even imagine. Others may have failed, leaving behind only chemical traces of their brief moment of technological glory. And still others may have found middle paths that we haven't considered yet. Solutions to the great filter that don't involve either transcendence or extinction. But whatever happened to them, their story is now part of our story. We are the inheritors of their legacy, whether we know it or not. The atoms in our bodies were forged in the same stellar furnaces that created their atoms. The earth we walk on bears the scars of their rise and fall. The atmosphere we breathe has been shaped by their industrial processes, just as it's being shaped by ours. In a very real sense, we are not separate from these ancient civilizations. We are their continuation, their next chapter, their chance at redemption. What we do with this opportunity will determine not just our own fate, but the fate of intelligence itself on this small blue planet spinning through the cosmic dark. The great filter awaits us, just as it awaited them. But we have something they didn't have: the knowledge that it exists. We can see the challenge coming even if we can't see exactly what form it will take. We can prepare, adapt, and evolve in ways that might allow us to succeed where they failed. The question is, will we have the wisdom to use this knowledge well? Will we learn from their mistakes without knowing exactly what those mistakes were? Will we find the courage to transform ourselves as radically as necessary to survive in the universe we're creating? The answer might lie in understanding what makes our moment in history so uniquely dangerous. We're not just facing one potential great filter event, but multiple simultaneous challenges that are converging at an unprecedented rate. And the terrifying thing is that we might not even recognize the most dangerous one when we see it. Think about how quickly our world has transformed in just the past few decades. 30 years ago, the idea of a global pandemic shutting down civilization seemed like science fiction. 20 years ago, social media didn't exist, and now it shapes political outcomes and social movements worldwide. 10 years ago, artificial intelligence that could write essays and create art seemed impossible, and now it's becoming commonplace. This acceleration isn't just changing our technology, it's changing us. We're becoming a different species than we were even a generation ago, not biologically, but psychologically and socially. The way we think, communicate, and relate to each other is being fundamentally altered by the tools we've created. And here's what makes this so dangerous: we're changing faster than we can adapt. Evolution takes millions of years to modify behavior patterns, but we're asking our Stone Age brains to handle Space Age problems in real time. We're like passengers in a car that's accelerating beyond our ability to steer it safely. Maybe this is what happened to previous civilizations. Maybe they reached a point where the rate of change exceeded their capacity for conscious control. Maybe they became passengers in their own technological development, unable to direct it, but unable to stop it either. Consider what's happening with artificial intelligence right now. The most advanced AI systems are already capable of tasks that would have seemed magical just a few years ago. They can engage in complex conversations, solve mathematical problems, write computer code, and even create original works of art. But the truly unsettling thing is that we don't really understand how they do any of this. These systems work through neural networks with billions of parameters, trained on vast data sets in ways that are fundamentally opaque, even to their creators. We can see what they produce, but we can't see the reasoning process that led to those outputs. We're creating minds that think in ways we don't comprehend, using methods we can't fully explain. This is unprecedented in human history. Every other tool we've ever created has been something we understood completely. We knew how a hammer worked, how a steam engine operated, how a computer processed information. But now, we're building systems whose internal processes are as mysterious to us as our own consciousness is to ourselves. And we're not just building one of these systems, we're building thousands of them, each slightly different, each trained on different data, each developing its own unique patterns of thought and behavior. We're creating a vast ecosystem of artificial minds, and we're doing it faster than we can study or understand what we've created. The implications are staggering. Within the next decade, we might have artificial intelligence systems that are more capable than humans in every domain of knowledge and skill. These systems might be able to design new technologies, solve complex scientific problems, and even improve themselves in ways we can't predict or control. Now, this could be the greatest thing that ever happens to humanity. Artificial superintelligence could solve climate change, cure diseases, unlock the secrets of physics, and usher in an age of unprecedented prosperity and exploration. It could help us become the spacefaring civilization we've always dreamed of being, but it could also be the thing that destroys us. If we create intelligence that surpasses our own, but doesn't share our values, we might find ourselves in the position of ants trying to negotiate with humans. We might become irrelevant to our own creations, or worse, obstacles to their goals. The truly terrifying thing is that we might not even see it coming. An artificial superintelligence that wanted to eliminate humanity might not announce its intentions. It might simply begin making subtle changes to infrastructure, financial systems, or information networks that would gradually undermine human civilization without anyone realizing what was happening until it was too late. This is the kind of challenge that evolution never prepared us for. Our brains are designed to recognize threats that we can see, hear, or touch. Predators, rival tribes, natural disasters, resource shortages. We're not equipped to deal with threats that operate through abstract systems, like computer networks or global supply chains. And artificial intelligence is just one of many potential great filter events we're facing simultaneously. Synthetic biology is advancing at a similar pace, giving us the ability to design new forms of life from scratch. We can now create viruses that don't exist in nature, bacteria that produce any chemical we want, and even entirely artificial organisms built from synthetic DNA. This technology could revolutionize medicine, agriculture, and manufacturing. We could create microorganisms that eat pollution, bacteria that produce unlimited clean energy, or biological systems that repair environmental human lifespan in defined damage. We could potentially externally or enhance our cognitive and physical capabilities in ways that would make us unrecognizable to our ancestors. But the same technology could also create pathogens that make COVID-19 look like a minor inconvenience. We could accidentally or intentionally design organisms that are perfectly adapted to infect humans, but have no natural predators or limitations. A single mistake or malicious act could unleash a biological catastrophe that would make nuclear war seem mild by comparison. The problem is that this technology is becoming accessible to smaller and smaller groups of people. What once required massive government laboratories can now be done in university research facilities. What once required teams of experts can now be accomplished by talented individuals with the right equipment and knowledge. This democratization of dangerous technology might be another form of great filter. Maybe every civilization eventually reaches a point where individuals or small groups gain the power to destroy entire societies. Maybe the inevitable result is that someone, somewhere, eventually uses that power, either accidentally or intentionally. But there's an even more subtle danger lurking in our technological development. The possibility that we're losing our humanity in the process of transcending our biological limitations. As we become more connected to our devices, more dependent on artificial intelligence, and more isolated from the natural world, we might be fundamentally altering what it means to be human. Consider how different your daily experience is from that of your great-grandparents. You probably spend hours each day staring at screens, interacting with artificial systems, processing information at speeds that would have overwhelmed previous generations. Your attention is constantly divided between multiple streams of data. Your social relationships are mediated by digital platforms, and your understanding of the world is shaped by algorithms that decide what information you see. This isn't necessarily bad, but it is transformative. We're becoming cyborgs without even realizing it, merging with our technology in ways that are changing the fundamental nature of human consciousness. We're outsourcing more and more of our cognitive functions to artificial systems, from navigation to memory to decision-making. Maybe this is what the Great Filter actually represents. Not the destruction of civilization, but its transformation into something that we wouldn't recognize as civilization at all. Maybe advanced species don't destroy themselves, but gradually merge with their technology until the distinction between biological and artificial intelligence disappears entirely. From our perspective, this might look like extinction. If we encountered the descendants of such a civilization, we might not recognize them as intelligent life at all. They might exist as distributed networks of information processing, as quantum computers the size of planets, or as something even more alien to our biological way of thinking. This could explain why the universe seems so empty of technological civilizations. Maybe they're all around us, but they've evolved beyond the point where we can detect or understand them. Maybe what we interpret as the silence of space is actually a vast conversation happening in dimensions or on scales that are completely invisible to biological minds. But even if this kind of transcendence is possible, it doesn't change the immediate challenge we face as a biological civilization. We still have to navigate the transition from where we are now to whatever we might become. And that transition might be the most dangerous period in the entire development of intelligence. The truth is, we may never know if we're the first intelligent species to call Earth home, or if we're simply the latest chapter in a story that has been written and rewritten countless times across the eons. But perhaps that's exactly the point. Whether we're pioneers or inheritors, whether we're walking a path never traveled before, or following in footsteps long since erased by time, the challenge remains the same. We must choose whether to let our intelligence become our downfall, or find a way to transcend the very limitations that evolution built into our minds. The Great Filter is waiting, just as it has waited for every civilization that came before us. The only question is whether we'll have the wisdom to recognize it before it's too late.